So the other day, this light bulb should have lasted. It's an LED, of course, as you can see. Should have lasted. Um, they say 100,000 hours or whatever. It only lasted a few weeks and it burned up. That's a Chinese cheap-made light bulb. Even though some of these things have um, a name of company that makes other things, but I've seen this before. So anyway, so this was glued here with a silicone, and this is fits down here like that, right? So I took this apart, and then I pried open this dome, which is plastic. It bounces nicely. Okay, and then I cleaned the silicone around here, and believe it or not, there isn't much. So this is just in a heat sink. So is this part here, which is just aluminum, and so is this. And the heat spreads through this onto this, and then it goes radiates out through that. And so that's how the heat's working. So in here is a capacitor that can be recycled, and I can just like remove it, and maybe I have to desolder it first. I don't know if it's gonna come apart or not. It looks like if I put my extra eyes on, let me see, is that soldered? No. Oh, it's a socket that when you push it in, okay, so I finally took it apart by rocking it back and forth. So what you do is when you push this in, there is a little latch on both sides, make contact like that, and holds this capacitor. And so I now pulled it out, and looks like this is the same thing. So there is a resistor right here. So let's see, let's pull this out. And then this is just a wire. And again, it's just stuck through this little socket so that they don't have to solder it. Okay. And let's see. It says right here 94 volts. Okay. So it would take 94 volts to turn on all of these LEDs. And so they are connected in series. As you can see, there's also numbers around the edge. And it starts over here within a, let's see, is that a 0? 8, 7. That's interesting. So here's numbers 8, 7, 6, 5, 4, 3, 2, 1. Okay, starts right here with that LED, and it goes counterclockwise. No, clockwise, I'm sorry. They are soldered in. And basically what's happening is the capacitor is there to even up the sine wave. And this is a resistor that would protect that thing from getting too many amps. So it just needs very small amount of amperage. And then this here is an isolator that isolates the electronics uh, from the spikes or whatever. And these two are transistors or MOSFETs more likely. And then this is R2, so that's definitely a resistor, and so is that one, R1. And then there's one more resistor over here. Otherwise than that, there is really nothing to it. It used to was that there was a little transformer in here that reduced the voltage, but now they're doing it with a resistor, capacitor, a couple of MOSFETs probably, and and um, and then of course the isolator, but that just isolates things that usually like an opto isolator. And this they don't have any markings on them, not that I can see. even with magnifying glass. And it'll be kind of interesting to see if the LEDs are still working or not. And so what I'll do is I'm going to pull this wire out. We won't need it, so I'll just dump it. And so is this resistor. I think it's a resistor. I don't think it's going to be anything else. We'll find out in a second here. This heat shrink. There we go. Okay. This does not look like a resistor. This looks like, what the heck is this? It definitely got hot because this heat shrink is completely bonded. Maybe it is a resistor, but we'll find out. If you want to know for sure, then what we'll do is we'll measure it. There we go. We have a little, I call it gizmodo, which is a thing that measures just about anything. So we'll turn the power on. And what we want to do is test. And it's going to, of course, come out with the damage because there's nothing connected. So we'll put it between pin 1 and 2. Close this. And then hit test again. Oh, wow. It's not working at all. That's probably what made it so it's not working. Let's try it between pin 3 and 2. Let's see if this will measure anything. Oh, it's a damaged part, and there is no, at least I cannot see any markings on it. So this may be a fuse. This may be a fuse. So why don't we test that very quickly? I don't know if you heard the beep, but my meter, I just put it in measuring continuance. Yep. So this is a ceramic piece. That's a fuse. So that's what this is. It's just a fuse. It looked like a resistor, but it's a fuse. And it got hot, and then it, of course, died. So it's more likely that this is going to work if I use my little tester. So let me go ahead and grab my tester, plug it in, and I'll be right back. Okay, so here is my LED tester. So this tests the LEDs inside your TV set, which is the backlit, or any other LEDs, including this one. And this will tell us how many volts and how much current it needs to light up. So watch this. This is really nifty. So I'm going to put this probe on in this hole right here. And then this one on here. There we go. And as you can see, it's pretty blinding. And so let's do this one more time. Because I'm going to have to put this over here so I can actually see. So 144 volts you can pump in here, and it uses 0.69 amps. So this thing was supposed to reduce the voltage down to 96 volts, but it looks like that you can use lower voltage and then correct the brightness just by using a higher voltage. So once it starts lighting up, which was fairly early, let me see if I can capture that when it started. Oh, it's 120, 100, well, 120 volts, I guess. So 120 volts and zero point 0.7 amps, 6.69. So that's that's surprising. Usually, when it says on here 96 volts, it usually means that it needs 96 volts, and otherwise you can burn it up. But again, this tester here, you know, is it, I bring it into the picture. Oh, I must have knocked my camera again. Sorry about that, guys. So this tester is really, really good. I've used this for all kinds of things. So I know that I can toss away those three items. I can keep the capacitor. There's nothing wrong with the capacitor. So I put it over here in my recycle. And then this I can reuse just by putting a voltage in here. And so I'm gonna play with it, and you can put in AC or DC because that's what this actually. You know what? This is probably a diode, uh, and uh, and it converts the AC to a DC instead of an isolator, like an opto isolator. It looked that way, but it's I'm changing my mind. So anyway, so that's what inside these LED light bulbs is in this instance. Some of the other models, as I said, had a little transformer, and then some electronics and a big capacitor. And usually that capacitor blew up because it's, as I said, it's cheaply made and it's very, very, you know, questionable quality on many of these made in China. It's you know they don't they want to sell more light bulbs, of course, so they make them so they die a little bit earlier than what they advertise on the box. Alrighty, uh, give me thumbs up and go ahead and have a fantastic day.